Hi class, welcome to exercise 5G, applications of quadratics. In this lesson, your examples and pre-learning will be example 18, finding dimensions using quadratics. And please note that I've got more pre-learning than they suggest in the text, and that is questions 1, 3, 7, 8, 9 and 11 in the new book, and questions 3, 4, 7, 8, 9 and 11 in the old book. Then we're going to do a bonus section, which is not in the textbook, but is a very important skill and I think half of the learning in this lesson. And that will be called solving number problems with quadratics. And your pre-learning for this section will be 5, 6 and 10 in the new book and 5, 6 and 10 in the old book. Now be warned that this lesson is not possible if you can't solve quadratics. In my opinion, finding a quadratic in a worded question is challenging enough without having to backlearn solving quadratics. So please, if you aren't super confident with those, make sure you do the last lesson again or for the first time. Alright, I'll see you in the introduction. Where is the variable squared? That is the question. Quadratics will arise when we have constraints on two linear products and those constraints are related. So for example, if we were asked to draw a triangle that had an area of 10 centimeters squared, we could draw one with a height of 5 and a width of 4. And of course this has an area of base times height divided by 2, i.e. 4 times 5 divided by 2, which is 10. But I could also draw one that has a base of 20 divided by 3 centimeters and a height of 3 centimeters. And of course this one's area is 20 divided by 3 times 3 divided by 2, which is just equal to 10 centimeters squared. So in the end, we could have infinite solutions, as long as base times height divided by 2 equals 10, i.e. base times height is equal to 20. So you can see what I did in the second triangle there. So whatever height I think of, if I make a base of 20 divided by that height, this will satisfy our constraints. But what if there was a relationship between our height and base? For example, we said the base is 1 centimeter more than the height. So in other words, base is equal to height plus 1. But then we'd still have base times height divided by 2 equals 10, because this is still the area of a triangle. But with our defined relationship, we now have h plus 1 times h divided by 2 equals 10 when I sub in h plus 1 for b. So that means h plus 1 times h equals 20. And then we can rearrange that to be h squared plus h minus 20 equals 0 when we set it up for a quadratic solution. And of course this quadratic factors into h plus 5 times h minus 4 equals 0. And this can only be true when h is equal to negative 5 or h is equal to 4, just using the null factor law. But can we have a height that's negative? Well, of course not. So therefore, because it has to be positive, the only answer we have left is h equals 4. And because the base is equal to h plus 1, then the base would have to equal 5. Now, one of the biggest challenges with applications of maths is finding the clues in worded problems. When working with quadratics, it's important to know that there will be a product with an answer, like p times q equals r, and one of these factors will relate to the other. So for example, q will equal p plus a constant e. So the next step is to sub in the new value for q, so that our p times q equals r becomes p times p plus e equals r. Then you need to multiply through and rearrange for a quadratic solution. So an example above, multiplying through gives us p squared plus e times p equals r, which can be rearranged to p squared plus ep minus r equals 0. And once you get to this point, you're going to have to factor it and solve. Alright, again in this lesson, I want you guys to work on the building understanding questions in the new book, which translates to questions 1 and 2 in the old book. And then I'll see you in the next section. When working with areas, dimensions are the width and height. And not, as I always thought, just 2D. So if we know the area and can describe both the dimensions with the same variable, so for example, if our width was x plus d and our height was x plus e, because width times height equals area, then if we sub in the values we've given to the width and the height, we now get x plus d times x plus e equals area, which creates a quadratic. So then we just need to solve the quadratic for x and sub x back into the values for the width and height. Of course, you need to make sure that the values that you have make sense. Importantly, this means no negative lengths. Okay, let's get on with example 18, which is a problem about a rectangle with an area of 28 meters squared. And this rectangle has a length 3 meters more than its width. So the challenge is to find the dimensions of this rectangle, which, as you know, means the width and the length. If we let our width equal x, then our length has to be x plus 3, which just really means it's 3 more. Now, because width times length equals area, then subbing in x for w and x plus 3 for length, and remembering that the total area is 28, we then need to expand this to get a quadratic, and I have already moved the 28 over, and this quadratic x squared plus 3x minus 28 is how we prepare to solve the quadratic. Alright, hopefully you're super confident with this, but I already know that I can factor this as x plus 7 times x minus 4 equals 0. But you really should know this by now. Now this means that x is equal to minus 7 or x is equal to 4, just using the null factor law. Now of course minus 7 is not a length, and because w equals x, that means w equals 4, and because l equals x plus 3, we get l's equal to 4 plus 3, which is 7. And of course we always finish a worded question with a worded response. So we say that the dimensions of the rectangle are width of 4 meters and length of 7 meters. Of course, you can check that 4 times 7 is 28, but I'm pretty sure everyone's confident with that one. Alright, so right now you should pause that video and work on questions 1, 3, 7, 8, 9 and 11 in the new book, or questions 3, 4, 7, 8, 9 and 11 in the old book. So this is more than is required, but they're simple enough, and completing these questions as pre-learning means you've got a lot more time in class to master the topic. They're all single question questions as well, so it won't take too long. Alright, I'll see you in the next section. Okay, I've decided to make this bonus section because this method can be used with number problems too. In fact, there's a number of examples in the exercise. So to help you prepare for those, I will do a little example here that's different to any of those. Alright, so in this example, the question is, find the product of 2 consecutive integers, that is 56. So we're going to have to define the relationship between these two numbers. Now, if we let n be an integer, then n plus 1 is the next one. So one integer and the next one are the 2 consecutive integers. So if I was to write an integer times the next one equals 56, that's just n times n plus 1 equals 56. Expanding these brackets will now give us n squared plus n equals 56, which can be rewritten as n squared plus n minus 56 equals 0, as we prepare to solve this quadratic. Okay, so this quadratic can be factored as n plus 8 times n minus 7 equals 0. So therefore, n's equal to minus 8 or n's equal to 7 just by using the null factor law. And sure enough, 7 times 7 plus 1 equals 7 times 8, which is 56. And minus 8 times minus 8 plus 1 is equal to minus 8 times minus 7, which is also 56. So we get 2 ticks there. And the actual answer to the original question is stating that our factor pair is either 7 and 8 or minus 7 and minus 8. Of course, you should check whether negative numbers are accepted, but here they are. They just said integers. Alright, so at this stage, I think you should pause the video and do questions 5, 6 and 10 in the new book, or 5, 6 and 10 in the old book. And then come back and we'll summarise this lesson. While I have set more pre-learning than the text suggested, it really isn't a lot. But this is because this topic is vital for future success. So it's really important that you come to class with all of these questions attempted or complete. Okay, in this class, a successful student will be able to set up a quadratic equation from a worded problem, know how to apply the steps for solving a quadratic equation, and finally, understand and check the validity of solutions in the context of the given problem. Okay, good luck with all that, and we'll see you in the next lesson, whether that's in class or the next video. Bye.